What if the Big Bang wasn't a beginning at all, but more like a middle? Not the first page of the universe's story, but maybe page 10,000 of an infinitely longer book you were never shown. Here's what bothers me. We named it a bang, which already tells you everything about how humans think. We needed a sound, a starting gun, a moment to point at and say, there. That's where it started, but the universe didn't ask for our comfort. It didn't arrange itself around our need for a clean origin story. So what if, just what if, asking what came before the Big Bang isn't a stupid question? What if it's the only question that matters? I want to stay with that for a moment before we go anywhere else. Because I know what happens when most people ask that question in a classroom, or at a dinner table, or in a comment section somewhere. Someone with a confident voice, a teacher, a documentary narrator, a very smart friend. They smile that particular smile, the patient smile. And they say, well, the question doesn't really make sense. Time itself began at the Big Bang. There is no before. Asking what came before the Big Bang is like asking what's north of the North Pole. And you nod. Because that's a beautiful answer. It's elegant, it has a certain finality to it. And you walk away feeling like you just learned something profound. But somewhere in the back of your mind, and I mean the very back, the part you don't usually let talk at dinner, something keeps pulling at you. Like a loose thread. Like a door that looks flush with the wall but has a draft coming through it. You felt the draft, didn't you? That's why you're here. That draft is real, and today we're going to walk through that door together. I have spent my entire career being suspicious of clean answers, not because I enjoy being difficult, though, if I'm honest, there's some of that, but because in my experience, the cleaner an answer sounds, the more likely it is that someone smoothed off all the interesting edges to make it fit through the door of public understanding. And physics, real physics, the kind that happens in papers and arguments and late nights at blackboards, real physics is almost never clean. It is almost always stranger, messier, more uncertain and more breathtaking than whatever version got summarized for the textbook. So here is what I want to give you today. Not a debunking. Not a conspiracy theory about scientists hiding the truth. What I want to give you is something much more valuable than a new answer. I want to give you a better relationship with the question itself. I want to show you the exact place, the precise intellectual moment where even brilliant people sometimes stop asking. And I want to show you why you should keep going, why the question, what came before the Big Bang, is not a malformed question. Why it is, in fact, one of the most alive, most generative, most important questions that physics is actively wrestling with right now. Not in the fringe, not in the pseudoscience newsletters, in the journals, at the conferences, in the work of some of the most serious minds that have ever pointed themselves at the sky. But here is the other thing I want to give you, and this is the part that might surprise you. Because this video is, on its surface, about cosmology. It's about the origin of the universe, about time, about what the mathematics of reality actually says when you read it carefully, rather than just summarizing it for a test. But underneath all of that, underneath the physics, this is a video about what happens to a person when they stop needing a clean beginning, when they realize that the most important things in their life, the things that shaped them, the things that broke them, the things they've been carrying, don't actually require a fixed, definitive point of origin story. And that realizing this isn't loss, it's the beginning of something much more interesting than certainty. So let's start where every good question starts, not with an answer. With a picture, I want you to imagine a river, but not from the bank. Don't stand on the shore and watch it go by. I want you to imagine that you are inside the river. You are the water. You have no memory of the mountain spring that fed you. That was a long time ago, and water doesn't keep diaries. You have no sense of the ocean somewhere ahead of you, though something in the way you move suggests a direction. All you know in any immediate and real sense is this: the current, the cold, the particular pressure of being surrounded by more of yourself, The way the rocks on the riverbed break the flow into tiny temporary whirlpools that disappear almost as soon as they form. Now, someone standing on the bank, a very smart someone, a well-meaning someone with good instruments and genuine curiosity. That person points upstream. They've been watching the river for a long time. They've traced it back as far as their legs could carry them. And they point at a waterfall, maybe a mile upstream, a dramatic and thunderous place where the river drops off a shelf of granite and crashes into the pool below. And they say, that's where the river began. And here's the thing, they're not wrong exactly. The waterfall is the most visible dramatic event in the river's history. Everything downstream from the waterfall has the character it has partly because of what happened there. The water picked up minerals from that particular rock. The velocity of the fall shapes the current for miles. The waterfall is real and it matters, and the person on the bank who found it has done something genuinely impressive. But you, inside the water, you know something. The water that went over that waterfall, it was already the river before it fell. It had a history before the dramatic moment. It came from somewhere. It was shaped by 1,000 subtle things: snowmelt, underground springs, the particular tilt of the land, before it ever reached that shelf of granite and made that spectacular noise. The waterfall is not the beginning of the river. The waterfall is the beginning of the river that the person on the bank can trace. These are two completely different things, and confusing them, quietly, naturally, without even noticing the confusion, is one of the deepest and most human of intellectual habits. The Big Bang is our waterfall. I need to say that again because it deserves to sit with you for a moment. The Big Bang is our waterfall. It is magnificent. It is real. It is one of the most well-supported events in the history of scientific discovery. The evidence for it is extraordinary. The cosmic microwave background radiation, the distribution of hydrogen and helium in the universe, the fact that everywhere we look, galaxies are moving away from each other, which means if you run the movie backwards, everything was once much closer together, much hotter, much denser. All of that is real. All of that is as solid as science gets. But, and here is the draft through the door, the Big Bang being a real and important event in the universe's history is not the same thing as the Big Bang being the beginning of time itself. One of those is a cosmological observation. The other is a philosophical claim dressed in scientific clothing. And for decades, those two things have been standing very close together, wearing the same outfit. And most people, including honestly a lot of science communicators who should know better, have been treating them as if they're the same person. They are not. Now here's where I need to tell you something about the physics, something specific, something that the textbooks almost never say clearly, even though every working physicist knows it, and most of them find it either fascinating or quietly embarrassing depending on the day. There is a moment in the very early history of the universe, the earliest moment that our current physics can describe, called the Planck epoch. It refers to the first 10 to the power of -43 seconds after the bang, which is a number so small, it genuinely has no meaning in everyday life. It's not like a millisecond, which you can at least sort of feel. It's a duration so brief that even the word brief is almost offensively inadequate. But here's the thing about the Planck epoch. At that scale, at that density, that temperature, that compactness, the two great theories of modern physics, general relativity and quantum mechanics, stop working. They produce nonsense. They give you infinities where there shouldn't be infinities. They contradict each other. They break. And this breakdown is not a minor technical inconvenience that physicists are getting around to fixing when they have time. This breakdown is the most important open problem in all of fundamental physics. We do not have a theory of quantum gravity, a framework that successfully unifies general relativity and quantum mechanics at the scales relevant to the very early universe. We are working on it. String theory is an attempt. Loop quantum gravity is an attempt. There are others, but none of them have been confirmed. None of them are settled. At the Planck scale, our map literally runs out, not because we haven't looked hard enough, because the instruments we currently have, the mathematical instruments, I mean the equations, They were not built for that terrain. Now, here is the point I need you to really feel. The singularity, the beginning of the Big Bang, the t=0 moment, sits inside the Planck epoch. It sits in the exact region where our physics stops working. Which means that when physicists say time began at the Big Bang, what they are technically saying, what the mathematics is actually saying, if you read it honestly, is our current description of reality breaks down at this point, and therefore we cannot say anything about what was happening before this point using our current tools. That is not the same as nothing was happening before this point. That is not the same as there was no before. That is the map running out. That is the road ending at a cliff. The land continues. We just haven't built the bridge yet. And the moment you understand the difference between our description breaks down here and reality itself breaks down here, something opens up. Something in the question that was sealed shut gets pried open just a little bit. And through that crack you can see something remarkable. You can see that some of the most serious physicists in the world have been building different bridges. And while those bridges look quite different from each other, they all lead somewhere. They all suggest that the universe, in some form or another, did not begin when the story we can currently tell begins. Let me show you 3 of those bridges, and I want you to treat them not as competing answers to memorize, but as 3 different ways of standing at the edge of the unknown and choosing to lean forward rather than back. That, leaning forward, is, in my opinion, the most important thing a curious mind can do. The first bridge belongs to Stephen Hawking, working with James Hartle. It's called the No-Boundary Proposal. And to understand it, I want you to think about something beautifully simple. Think about the South Pole. Not the cold, not the penguins, just the geometry of it. The South Pole is the southernmost point on Earth, and here's a question: what is south of the South Pole? Take a moment with that. Most people, when they really sit with it, start to feel the question become strange in their mouth. It's not that the answer is nothing. It's that the question itself starts to dissolve. The South Pole is the point where south as a direction simply ceases to apply. You can't go further south than the southernmost point. It's not that there's a wall there. There's no wall. There's no beyond that is being blocked. The concept of further south just stops being a concept that works. Hawking and Hartle proposed that something structurally similar might be true of time near the Big Bang. They suggested that under extreme conditions, the kind of conditions that existed in the very early universe, time itself might have behaved more like a spatial dimension. It might have become rounded, the way the surface of the Earth rounds at the poles, and if that's true, then asking what was before the Big Bang isn't a question that's being blocked by a wall. It's a question whose terms, before, after, beginning, simply stop meaning what they usually mean. The concept dissolves, not because someone decided to forbid the question, because the geometry of reality in that regime doesn't have a place for before to live. Now, I want to be careful here because this is subtle. This is not the same as saying nothing happened before the Big Bang. It's saying that the category of before may not be the right tool for that job. It's saying that our temporal language, which works beautifully for everything from planning lunch to describing the history of civilizations, runs into its own kind of grammatical breakdown when applied to the deep architecture of space-time at extreme energies. And if that sounds strange and uncomfortable, good. That's what accurate thinking about the edge of knowledge feels like. If it felt comfortable, you'd know you hadn't really gone there yet. The second bridge was built by Roger Penrose. And I find this one genuinely beautiful, in a way that makes me feel something I can only call gratitude to be alive in a time when humans think thoughts like this. Penrose proposed what he calls conformal cyclic cosmology. And here's the core of it. Imagine the very far future of our universe. Not the next billion years, much further. The universe continues to expand. Stars burn out. Black holes eventually evaporate through a process called Hawking radiation. The universe becomes increasingly cold, increasingly thin, increasingly empty. Matter as we know it eventually decays. What you're left with, at the absolute end of this cosmic story, is a universe populated essentially only by photons. Light, moving through an increasingly vast, cold, empty space. Now here's the mathematical magic that Penrose noticed. In a universe containing only massless particles, particles moving at the speed of light, like photons, something peculiar happens to time. Massless particles don't experience time the way massive objects do. For a photon, the journey from here to the edge of the observable universe is, in a certain mathematical sense, instantaneous. A universe of pure light is a universe in which the conventional measurement of scale, of distance and duration, becomes meaningless. And Penrose recognized that a universe in this state is, in a deep mathematical sense, geometrically identical to a universe in an extremely hot, extremely dense, extremely compact early state. The cold, empty end of one cosmic cycle and the hot, dense beginning of the next are, under this framework, the same geometric object looked at from different directions. The end is the beginning, not metaphorically. Mathematically, the universe doesn't die and give birth to a new universe. It transforms smoothly and continuously from what looks like an ending into what looks like a beginning, with no break in between, no creation event, no moment of nothing. Time doesn't begin. Time loops, or more precisely, time transforms in a way that makes loop the closest word we have, though even that isn't quite right. There's a picture I carry with me when I think about this. A phoenix, but not the mythological kind made of fire and drama. A phoenix made of mathematics. A universe that transforms its ending into a beginning not through magic, but through the elegant and remorseless logic of geometry. I find that image more astonishing than any myth. The third bridge comes from a field called loop quantum cosmology, and this one is perhaps the most viscerally imaginable of the three, because it gives us something we can feel in our bodies if we try. You have, at some point in your life, compressed something. Squeezed a ball in your hand, pushed the air out of your lungs. You know that there is a resistance that builds as something gets compressed, a pushback, a pressure that grows as the thing gets smaller and denser. Now imagine compressing the entire universe. In the standard Big Bang model, this compression just keeps going, smaller and smaller and hotter, until you hit a singularity, a mathematical point of infinite density, and the equations break. But in loop quantum cosmology, there is a fundamental quantum of geometry, a smallest possible size. Space itself, at the Planck scale, is not infinitely divisible. It has a kind of granularity, the way a photograph has pixels. And when the universe compresses all the way down to that scale, the quantum geometry creates a repulsive force, a pressure that pushes back against infinite compression. The universe hits its smallest possible state, not a singularity, not infinite density, but a maximum density that the quantum geometry can support, and then it bounces. It bounces outward. The contraction becomes an expansion. What we call the Big Bang is, in this picture, the moment of maximum compression in a previous cosmic cycle, the moment the universe stopped collapsing and began to expand again. Our universe is on the other side of a cosmic breath held to its absolute limit and then released into everything we know. Think about that image, a breath held until it can be held no longer, and then released. Time doesn't begin at the Big Bang in this picture. Time passes straight through it, the way a river passes through a waterfall. The waterfall is real. The waterfall is dramatic. But the river was already the river before it fell. Now, you might be sitting there thinking, okay, but which one is right? Hawking and Hartle? Penrose? Loop quantum cosmology? And I want to answer that question with something that, the first time someone said it to me, I found almost offensive. And then, eventually, I found it to be one of the most liberating ideas I'd ever encountered. We don't know. Not, we're close to knowing. Not, scientists are pretty sure it's one of these. We genuinely, honestly, carefully don't know. All three of these frameworks are internally consistent. All three are taken seriously by serious physicists. None of them has been confirmed by experiment. The domain in question, the Planck epoch, the first moments of the universe, is so extreme, so far outside anything we can recreate in a laboratory, that direct experimental confirmation may not be possible for a very long time, maybe ever. We are reasoning about it with mathematics and logic and theoretical consistency, the way you might reason about a crime scene from the physical evidence left behind long after the fact. And here's what I want you to understand about that. The fact that we don't know is not a failure. It is not an embarrassment, it is not a reason for cynicism or despair about the reliability of science. It is science working exactly as it is supposed to work, reaching its current frontier, marking that frontier honestly, and standing at the edge with openness instead of premature closure. The failure, if I want to use that word, is not in the physics. The failure is in how we talk about the physics. It is in the documentary narrator who says, "The universe began 13.8 billion years ago," without the asterisk that says, "at least as far as our current description can take us." It is. In the textbook that draws a timeline beginning at the Big Bang without acknowledging that the question of what sits before that point is actively open. It is in the teacher who silences the student who asks, "But what was before that?" with the South Pole analogy, which is, I want to be very clear, one possible and genuinely interesting answer, but not the only possible answer, and not a settled fact. The question is open. It is gloriously, productively, thrillingly open. And you are right to feel the draft through the door. There is something else I want to tell you. Something that is, in my experience, the most important thing you can take away from any serious engagement with the frontier of physics. It has to do with the psychology of certainty and why certainty, particularly about origins, is so seductive that it can become a trap even for very smart people. Here is a pattern I have noticed. When a scientist reaches a beautiful conclusion, a clean, elegant, final-seeming answer to a hard question, there is a very specific danger. The danger is not that they will get it wrong. Everyone gets things wrong sometimes. That's built into the process, and it's fine. The danger is that they will fall in love with the elegance of their answer and stop noticing the questions that the answer itself generates. The solution becomes a new lens, and the new lens becomes a new limitation. You start seeing everything in terms of the beautiful thing you found, and you stop noticing the shapes that don't fit. The Big Bang is, in a way, a victim of its own elegance. It is such a successful and genuinely astonishing framework for describing the early universe that it began to function in the public imagination as an origin story. And origin stories have a very specific gravitational pull on the human mind. We need them. We build our sense of identity, our sense of meaning, our sense of continuity around them. The universe had a beginning. Our nation had a beginning. I had a beginning, a birth date, a particular set of circumstances, an origin that explains what I became. And there is real value in those stories. I am not here to take them away. A person who has no story of where they came from is often a person who is lost. Origins matter. They provide context, they provide meaning, they anchor us in something larger than the present moment. But, and here is the thing that I want to sit with you in for a moment, because this is where the physics and the personal become the same conversation. The stories we tell about our origins are always simplifications. They are always partial. They are always, in a deep sense, the candle in the fog rather than the full illuminated room. Every person I have ever known, and I mean every single one, carries at least one story about when they became what they are, when they became afraid, when they became small, when they became the kind of person who doesn't get certain things, or doesn't deserve certain things, or is fundamentally different from the people who seem to move through the world with ease. There is a moment they point to, a waterfall, a beginning. Ever since this happened, I have been this way. And I want to ask you, gently and seriously, the same question that loop quantum cosmology asks about the universe. What if that moment, As real and as significant as it was, what if it was a bounce? Not a beginning, a bounce. What if the thing that felt like a creation event, like the moment you were made into whatever you're afraid of being, was actually a moment of maximum compression in a process that had been going on much longer? What if the river was already the river before it hit that waterfall? I am not asking you to minimize what happened to you. I am not asking you to pretend that the waterfall wasn't loud and cold and frightening. It was. Real waterfalls are. But the river exists before the waterfall. The river continues after the waterfall. The waterfall is not the definition of the river. And here is the neuroscience underneath the metaphor, in case you want something more grounded than poetry. The stories we tell about our origins, the narratives that begin with "ever since X I have been Y," those narratives are not passive records, they are active processes. Every time you recall and retell an origin story, you are literally reshaping the neural pathways that store it. Memory is not a photograph. Memory is a reconstruction, and it is a reconstruction that is influenced every single time by who you are at the moment of remembering, which means that the story of your beginning is always being written in the present tense, even when it feels like it's describing the past. Which means that the question, is this origin story the whole truth, or is it the candle in the fog, is not a question about the past. It is a question you are answering right now in the act of remembering. It is a present tense question with a present tense answer. And you have more choice in that answer than you might think. This is not a self-help platitude. This is physics applied to selfhood. The map is not the territory. The story is not the life. And the moment you understand that even the universe's beginning might be a story we're telling about a map that runs out, rather than a fact about where reality starts, well, something in the chest loosens. The question of where you began loosens with it. So let me give you something practical. 3 things you can actually do, starting today, with what we've been talking about. Not because I want to turn a physics lecture into a self-improvement seminar, but because I genuinely believe that ideas that don't change how you stand in your day are just entertainment. And I like entertainment, but I like it better when it also changes something. The first thing is what I call the origin story audit. And it's very simple, which means if you actually do it, it will probably be more powerful than it sounds. Take one story you tell about yourself that contains the phrase, or the feeling of the phrase, "Ever since this happened, I have been this way." Just one. Write it down as a single sentence if you can. Try to be specific, not "ever since I had a hard childhood." That's too large to work with. Something smaller and more precise. Ever since I failed that test in front of the whole class, I've believed I'm not smart. Or, ever since that relationship ended the way it did, I've believed I'm too much for people to handle. Write that sentence, hold it, and then ask the physicist's question, is this moment actually the beginning? Or is it the first thing you could clearly see from where you were standing? Is it the waterfall, dramatic, visible, formative? Or is it actually the beginning of the river? What was already in you before that moment that made the moment land the way it did? What had been building? What existed in the fog before the candle? You don't need to answer that today. You don't need to rewrite the story. The act of asking is enough, because the act of asking is how you distinguish between the map and the territory. And the moment you notice that your origin story might be a map, you have already expanded the territory slightly. The room gets bigger just from the question. The second thing I want to give you is what I call sitting at the plank wall. This is a brief daily practice, and when I say brief, I mean it takes about 1 minute, maybe less. Once a day, morning coffee, evening walk, a moment in your car before you go inside. Ask yourself this. What is the question I have been refusing to ask because it seems like it doesn't make sense? What is the thing I keep almost thinking about and then steering away from? What is the door that has a draft coming through it that I keep not walking through? Write it down or just hold it. Don't demand an answer from yourself. The question is the practice, the Planck wall in your own life, the place where your internal equations produce nonsense, where you run into infinite confusion or infinite resistance. That wall is not a sign that you've hit a dead end. It's a sign that you are standing at your own frontier. That's the place where the most interesting thing that could happen to you is waiting. And learning to stand at that wall without panicking, with curiosity instead of dread, is one of the most important skills a person can develop. It is exactly what distinguishes the physicist who goes beyond the known from the one who stops at the edge of the map. Comfort yourself with this. The universe has a Planck wall. Reality itself hits a place where its description breaks down and the equations produce garbage. And the universe is doing fine. It didn't freeze at that edge. It is, apparently, still going. So are you. The third practice is borrowed from the bounce cosmology, and I want you to use it specifically for the moments that feel most like endings. Relationship endings. Identity endings, the times when whatever you thought you were no longer seems to fit, and you don't yet know what you're becoming instead. The times of maximum compression. In those moments, not in spite of the pain, but right in the middle of it, try holding the following question. Not as denial, not as forced optimism, as a genuine structural inquiry. Try asking, what if this is the compression before the expansion? What if this is not the end of the story, but the part of the story where everything gets pressed so tightly together that the only possible next thing is an outward movement? What if I am, right now, at the point of maximum density, and the bounce is already built into the physics of this moment? I am not asking you to feel good about something that hurts. I am asking you to hold it differently. The universe's bounce was not comfortable. Maximum compression is, by definition, the place where everything is at its most intense. But the direction changed. The direction changed because the physics demanded it. And sometimes, more often than you might expect, that is also true of us. You don't owe your difficult moments an identity. You don't have to become what the hardest thing that happened to you would have made you. The bounce is real. The expansion is real. And it doesn't require you to pretend the compression wasn't what it was. Now, I want to come back to the physics one more time before we end, because I want to make sure I've given you the full picture honestly. There are people who will tell you that the questions I've been raising, the no-boundary proposal, conformal cyclic cosmology, loop quantum cosmology, all of it are speculative. And they're not wrong. All of these are speculative. They are well-reasoned, mathematically sophisticated, taken seriously by serious people, but not confirmed. We don't have the experimental data to choose between them, and we may not for a very long time. And I want to say clearly, that's okay. That is not a problem that needs fixing. That is the honest state of affairs at the frontier of knowledge, and honesty about the frontier is one of the things I value most in science and in life. What I want you to reject is the false certainty that runs in the other direction. The confident assertion that time began at the Big Bang is also speculative in the relevant sense. It is a claim about what was happening before our current physics can describe, which is a claim that our current physics, by its own admission, is not equipped to make. The silence of our equations at the Planck scale is not evidence that nothing was there. It is evidence that we don't yet have the right equations for that regime. And there is a profound difference between our tools don't reach there and nothing is there. We live in a time when uncertainty has gotten a bad reputation, when not knowing is treated as weakness, or as a failure of intelligence, or as an invitation for others to fill the vacuum with whatever they're selling. I understand why people react that way. Uncertainty is uncomfortable. The unknown is where fear lives. A clean answer, even a wrong clean answer, feels better than an honest, open question. But I have spent my whole life at the edge of what is known, and I want to tell you something about that place. It is not cold there. It is not empty. It is, in fact, the most alive place I have ever been, standing at the boundary of what can currently be described, with the full acknowledgement that something is there beyond the boundary. and that I don't yet know what it is. That feeling is not anxiety. When you get used to it, when you stop fighting it and start welcoming it, it feels like standing at a door that is about to open. It feels like the moment just before a really good question gets asked. And you know what that feeling is in the body? It is curiosity. Pure, uncontaminated, pre-answer curiosity. The feeling a child has before they've learned which questions are allowed and which ones make the grown-ups give that patient smile. I have been trying to get back to that feeling my whole life. I have found it most reliably at the exact places where the map runs out. You had that feeling too. That's why you're here. You felt the draft. So let me leave you with this. The universe, as far as our best and most honest physics can currently tell us, does not require a beginning. It does not need a t=0 to function, to exist, to be what it is. The appearance of a beginning may be a feature of our description rather than a feature of reality. The map has an edge. The territory, as far as we can tell, may not. What an extraordinary thing to sit with. What a gift that is, actually, if you let it be. Because if the universe can exist without a clear, definitive, universally agreed-upon starting point, if the cosmos itself is comfortable in the territory beyond the edge of the map, then maybe you don't need one either. Maybe the story of when you became what you are, when you were first broken or first limited or first made afraid, maybe that story has the same relationship to your actual self that the Big Bang has to the actual universe. Real, important, formative, but not the whole picture, not the beginning of the beginning, not the final word on what you are or what you are capable of becoming. You are not your origin story. You are the river, not just the waterfall. You were not created at the moment of your greatest compression. You were already moving before that. You will be moving after it. The bounce is built into the physics. And the questions you've been afraid to ask, the ones that seem malformed, the ones that get the patient smile, those are the most important ones you have. Those are the doors with drafts coming through them. Those are the places where your map runs out and the territory gets interesting. Don't stop at the wall. The wall is not the edge of what's real. The wall is the edge of what your current tools can describe. And new tools are built by the people who stood at the wall long enough to fall in love with what might be on the other side. The universe doesn't know exactly where it started. It's doing just fine. You don't need to know exactly where you started either. What you need to do is stay curious. Stay honest about what you don't know. Keep asking the questions that feel malformed. And trust the current you're already in, because the river was always moving, long before the waterfall, and it will keep moving long after. That's physics. That's also, I think, how to be alive. If something in this conversation gave you something real, if you felt, even for a moment, that the room got bigger, that the question you'd been told not to ask was actually a very good question, then we've been thinking in the same direction today, you and I. And I'm glad you're here. Hit like if this gave you something worth sitting with. Drop a comment with the question you've been afraid to ask. I mean that seriously. I love those questions more than almost anything. And subscribe if you want more conversations that start where the map runs out. That's where I'll always be, at the edge, leaning forward, listening to the draft. See you there.